Hi everyone, this is Oren, and today I'm going to talk about something that is lots of fun, putting RavenDB inside the Raspberry Pi. In order to have some reason to do that, I decided that we're going to take this user story. As a baker, I want to put my recipe in a digital form so I can manage them better, which is great, but it's not really interesting. So let's make this interesting and use the Raspberry Pi. If you don't know what this is, the Raspberry Pi is a $35 computer. It is used a lot for hobbyist IoTs, all sorts of interesting projects. The nice thing about it, it's cheap and it's small. It can fit in the palm of your hand, as you can see in the screen, and it's almost to the point where it's disposable. So let's see what we need to do in order to set up RavenDB on the Pi. So the first thing to do is, well, go to the RavenDB website, select download Raspberry Pi, download, and you're going to get something very similar to this. Now, I'm going to open Bash, and I'm going to log into the Pi. The only thing that I've done so far is just set up the Raspberry Pi, uh, plug it into my laptop. We're currently using direct network connection, and the Pi itself is completely empty. I'm going to get out of the Pi, and now I'm going to copy the RavenDB binaries from my machine to the Raspberry Pi. Log into the Pi again. Here is the file. And what I need to do now, I need to extract the file. This is a good time to mention that the Raspberry Pi is a pretty powerful machine. It is a quad core, has a 1 gigabyte of RAM, but right now the machine that I'm using has just an SD card for I/O, which means that in terms of I/O we are very poor. This is going to take quite a long time in terms of computing, as you can see by the fact that I'm speaking and see nothing. But we're going to wait in just a little bit more and we have everything done. So the first thing that I want to do is just run RavenDB, and hopefully everything will work. You can see that we have some system information. We're running on 32 bits, 4 cores, and our machine, and we have just under 1 gigabyte of memory available to us. And here's the first problem that we're going to run into. By the way, notice that what I'm doing, I'm running everything as you would do it. So if you were doing that on your own, you might run into those. So I'm going through all of the steps so you can see what's going on. I cannot log in into this device. Well, I could if I wanted to run something like links and command and browser, but I want to access RavenDB from my machine, from the laptop, not from the Raspberry Pi. So the first thing that I need to do, I need to set up and tell RavenDB how it should connect. And I told RavenDB that it should listen on the Raspberry Pi IP, and it's starting up. And I can take this URL, switch to home, and here we have RavenDB saying that we're running in an unsafe mode. And the reason that we're running in an unsafe mode is quite clear. We haven't set up any security whatsoever on the system. And that's a bad idea. It's a bad idea because if we just run RavenDB with no security whatsoever, anyone could come in and get data from our system. And this is practically the number one reason people's database get hacked, just because they put production database on the internet with no password. So in order to prevent that, RavenDB blocks this, but we know that we are actually running on a secure system. I have my corporate firewall running, I have the firewall on the laptop running, and no one can actually access to the Raspberry Pi. So I'm going to tell RavenDB, it's okay. You don't have to worry. Allow me to bind to this. And the only reason that I'm doing that is because I'm on a private network and I know that no one can access the data. Even so, let's see what happens when the server starts. And we have to go to legal stuff, blah, blah, blah. And this is where it gets interesting. So we are starting the server, and RavenDB, instead of opening into, show me some data, it shows me the setup result. I can run unsecurely. It's not recommended. I can also set up RavenDB in a secure mode. And I'm going to set up RavenDB using Let's Encrypt because that's the easiest mode to do that. Now, RavenDB wants a license key. The reason it wants a license key is because we're going to need to get a domain name. You can get a license key by going to RavenDB and get a free developer license and even a community license that you can use for production. I already done so, so I'm going to take this license, stick it here, and now, boom, here we go. So I'm going to want this domain. This is why we need the license, so we have the ability to tie this domain to a particular user and not just willy-nilly give people domains that they shouldn't have. I'm setting up a single node cluster with this URL. I don't need to do this because I'm not running on my machine. This is actually running on the Pi and I'm running on my laptop. And now this is going to run. This is actually going to fail, but let's see why it's going to fail. We can see that we're going to Let's Encrypt, update in DNS, and then we get an error. There's a whole bunch of text here. The underlying reason that for this failure is that we got a permission denied. I cannot bind to this. And if I go up, I can see that there is a very nice explanation that can explain why. We are trying to bind to port 443, and it's not allowed because we're not root. We could run RavenDB as root, but that would be a horrible idea. Instead, we're going to kill RavenDB and basically tell the system, hey, let RavenDB bind to let's RavenDB bind to this. Okay. And now we're running. Great. Let's hit the try again button. And we're going to run through all of this again. And we're starting validation. This is where we failed before. Now we are creating the configuration, everything. And now we hit this particular problematic issue. We're generating a client certificate. The way the security works with RavenDB is that we're using X49 certificate for everything. That means that over the wire, all of the data going through your production system is encrypted using TLS 1.2, basically HTTPS. This is the foundation of security on the network. However, it means in order to get proper security, we need to generate the client certificate. And RavenDB by default uses client certificate that are 4096 bits in size. The problem with that is that we are generating them on the Pi itself, and that can take a lot of time. The time ranges from 1 minute to 5 minutes. So effectively what's going to happen now is that I'm going to have a time skip because I assume that you don't want to sit and wait for 5 minutes while watching this thing spins. And now we're done. Notice a couple of interesting things. Here we have a whole bunch of interesting tidbits. You can see, where is it? Here we go. You can see that in this case it took almost 4 minutes for the client certificate to be generated, and we got something here, something that we download, the zip file. The zip file contains system configuration, and most importantly, it contains these guys. Let's take it out, and and I'm going to install the client certificate. This is how RavenDB is going to authenticate that the client is valid. So now we're restarting the service. And here we are. Notice something really, really interesting. This is the URL that we're using. This is safe, everything works. You can see that we're actually running on a 4 core and basically the details that we had before. Now, let's go ahead and create a database. We call it recipes. And let's go ahead and put some data in it. And now we're done. Here is RavenDB running on a Raspberry Pi with data, and the whole thing took me about 11 minutes. Now that we have RavenDB set up properly on the Raspberry Pi, the next thing that we want to do is actually do something with that. Now, RavenDB have support for multiple languages. I primarily work with C#, but we have clients for anything from C++, Go, and Node.js. And for this case, I want to use Python. I like the syntax, and it seems like a nice language that would be appropriate to use in a project involving the Raspberry Pi. So the first thing that I'm going to do, I'm going to need to make sure that I have Python 3 on the system. And I'm going to need to install the RavenDB client for Python, which I can do using this command. I've already done that, so we can save some time and we can start from scratch. The first thing that we need to do is define the model. This is what the document looks like. And I'm going to translate that into a fairly simple Python model. As you can see here, this is just exposing the raw data as is. The next thing that I want to do is to actually perform some sort of an operation. In order to do that, I'm going to use the following code. So let's see what we have here. We have an import of the RavenDB client for Python. We have the model that we previously defined, which contained the recipe. Here, this is the most important line. Here we say, okay, let's define a document store, which is how we access RavenDB. We provide the URL of RavenDB and the database that we want to use. We initialize the store, and then we are going to make a query. Give me all of the recipes that has the tag pi. If we're going to look at the data, this document doesn't have any pies in it, but PecanPy does have the tag of pi. That's pretty much it. Python 3 search. And let's see what's going to happen. Oh, that's a huge, big exception. But it's very clear what's going on. You can see here, forbidden access to this location. A certificate is required. And this makes perfect sense. Let's see what we have here. We define the URL, we define the database, but there is no authentication. Why should RavenDB allow us to access the database? So let's go to the database, and we're going to manage server and go to certificates. And here I'm going to hit generate client certificate, recipes. I'm going to grant read-write access to the recipes. Here as well, I'm generating the client certificate on the actual Raspberry Pi. This may take a while. Notice that another option that I have here is to use a pre-existing client certificate, one that I've created elsewhere, hopefully on a more powerful machine. Because of the time that it takes to generate a client certificate, we're going to have a time lapse again. As we saw before, this takes a few minutes to run. And here we go. You can see that we now have the cluster certificate. Sorry, we need to be clear on the term. This is the server certificate. This is what the server is using. This is the admin certificate. This is how I'm currently connecting to RavenDB. And what we have here is the new certificate that we just defined. And RavenDB doesn't actually keep a copy of that. This is the purpose of this zip file. And we're going to extract this. And let's go here. And exit. Here we go. So now I'm copying all of these files. Now nano search. And in order to make it work, I have to provide the recipes, CRT, and the recipes key files. This is basically the public and private parts of the X509 certificate that we're going to use to authenticate against RavenDB. And let's see what we have now. Oh, yes, this is because I'm using Linux, and this is a case-sensitive operating system. Notice, by the way, that I get a very clear error indicating what the actual problem is. Run it again. By the way, I intentionally do all of the development directly on the Raspberry Pi, just because I can. And it's sort of fun to do things through the command line. And what you can see right now is that we actually got something. We got 2 results. And here is a reminder, this is the code. So we are querying, give me all of the recipes that are tagged with a pi, and we just print them out. And here they are. If we go into the database itself, we can see something quite interesting. RavenDB went ahead and created an auto index for us. And this is important because if we have a lot of data, then that means that we're not going to have to deal with table scan and having to spend a lot of time just doing the query. By moving the course of the query completely into the indexing time, we save a lot of time and effort and get speed benefits that are just amazing. Now, so, okay, we get something, but we only get 2 documents. We get 2 documents because we don't have a pi here. Let's see what happens if I tag it with a pi. And I should get 3 results. And I do. Now, the interesting thing about this is that you can see that I'm doing that manually. That's not so fun. What happens if I want to actually do things programmatically? So let's go here. And I'm going to want to load the OnionPy document. Now, the reason that I need to specify the object type is that I don't have any types in the document itself. So Python doesn't know how to go from this dynamic JSON document to some type in my program. Now, I could work with dynamic types. It's generally easier to work with actual classes. So I'm specifying what type I want because I didn't generate the data directly. However, as you can see, if I'm working with Python, the RavenDB client will tell RavenDB what type we are actually using. We'll see that in a second. So we have the recipe, and we have tags, append, pi. Save changes. And we're done. Oh, yeah. Didn't I just fix that? Apparently not. Yeah, this is one of the annoying thing about Python, the case sensitive stuff. But at least, okay, at least I know how to fix it easy, and we run the code and we have a change. You can see that RavenDB tells us, oh, this document has been changed by something else. We refresh, and now we can see here is the pie that we added to the document. Here is the Python type. This is how the Python client can know what class to load when it accesses this document. But you know what? I don't like this. Let's revert those changes and let's enable a feature called revisions. What I'm basically asking RavenDB to do is whenever you're working and changing something in the system, I want you to create a revision for that. So the script run, I'm going to here, and here is the pie, here is the Python that I removed, the Python type, and here is a very interesting flag, has revisions. I can go here and look at this guy. Now I can see what changes were made in my system. I can also go back if necessary and all sorts of interesting stuff like that. So this has been RavenDB running on Raspberry Pi, being accessed through Python from Raspberry Pi, and we also looked just a little bit into how RavenDB does query and automatic indexes, how we can modify documents using Python. And you can see that this is really nice. Load the document, modify the in-memory object model, call save changes, and you're done. Everything works. We also explored just a little bit about the security mechanism around RavenDB, and we're done. We can now write our application on the Raspberry Pi that will talk to the local instance that we can access either directly from the Pi as we are currently doing, or from externally, as long as as long as we have access to the machine itself. So we have RavenDB running inside the Raspberry Pi. We have a Python client application talking to this instance of RavenDB. We can now build the whole recipe management system in Python, take the production server, which is a Raspberry Pi that fits in our hand, throw it in some cupboard, and we have the system. And that would be it in most cases. But I actually want to take it one step further and talk about cloud integration. So let's spin up a cloud instance of RavenDB. I'm going to use a private browsing instance of Chrome, so it will be very clear when I'm using the cloud instance and when I'm using the Pi instance. And you can see that Chrome is asking me to select a certificate. I didn't show it before when I set up the Raspberry Pi, but this is how I actually authenticate against the remote server. This is how RavenDB makes sure that not everyone can access your database. So I'm starting up the database for the first time, and you can see that I have 2 cores and 512 memory. And the funny thing about this is I made sure that I got an instance that is half as powerful as the Raspberry Pi, just because I find it incredibly funny to have a cloud instance that weak. So I'm going to just check where this is running. And you can see that this instance is actually running inside of AWS. So far, so good. So the one thing I want to do, let's create the recipes database. It's not a very interesting database on the cloud, but it's there. I have a cloud instance that can store data. The next step that I want to make is to push data from the Raspberry Pi to the cloud machine. Now, in order to do that, I need to create some sort of a trust system between these instances. So right now this is the Raspberry Pi, and I'm going to manage your server, certificate, and I'm going to ask the Pi, give me the certificate that you're going to use to authenticate against the remote machine. So I'm getting this guy, which is the uh, this is the public key that basically the public portion of the certificate that we will use to authenticate against a remote instance. And in the cloud instance, I'm going to certificate and I'm registering, I'm uploading a new client certificate. So that would be this guy, by instance. And I'm going to grant it access to the recipes, and we're good. Now, what I've done, I created this user, which is effectively the user that the Raspberry Pi is going to authenticate it as, and I granted it access to the recipes database. That's great. Now I'm going to settings, manage ongoing tasks, and I'm going to add an external replication. Push to cloud. External replication basically means, one second, not this one, I want this one. External application basically means that I'm going to push outside of my own cluster because the Raspberry Pi and the cloud instance are not tied together in any way, shape, or form. Now I created this, I'm pushing to the cloud. Let's see what happens on the cloud instance. And I can see that I actually got all of those results. Here is the onion pie. For that matter, let's see what happens when I'm changing stuff. Let's remove this pie stuff. It's immediately reflected in the cloud instance. So this is actually quite powerful. I have a local system, and any change that I'm making on that local system is reflected in the cloud. The only problem here is that this is a one-way system. And if you think about this, this makes a lot of sense. The cloud instance is publicly accessible. It's publicly addressable, not publicly accessible because we have security for that. But the Pi instance is actually running on a closed network. It's actually physically attached to my laptop and behind a couple of firewalls. So technically, I suppose I could go here and on the cloud instance, go the other way around. Say, oh, I want external replication from the cloud to the Raspberry Pi. The sheer amount of network hurdles that I will have to jump is staggering. I would have to open ports, set up NAT tunneling, do a whole bunch of crazy stuff just to get things working. It sucks. And I've seen people try to do that, maybe use SSH tunneling, all bunch of stuff. It's just crazy complex. But you don't have to do any crazy complex stuff. You can use this pool replication. The pool replication comes in two parts, and we're going to use both of them. Here is the pool replication hub. This is what we set up on the cloud. So on the cloud, we say publish recipes. And we need to generate a new client certificate. This is how users of that want to connect to us will authenticate against this system. And I'm going to export the configuration for that and just save this. And right now I'm done. I have a publish recipes from the cloud. And now I need to configure things from the other side. I'm going to go to ongoing tasks, and I'm going to set up the other side, the sync side of the pull replication. I'm just going to make things easy on myself and just import the configuration that we previously exported. And just hit save. And this is pretty much all I need to do. The Pi might take a few seconds to set up the connection. It's okay. Let's go here. And let's go to the cloud instance. The cloud instance, I'm going to make a change. And hit save. And you can see that it's reflected here. and on the Pi, I'm going to make a change. This is reflected here. So what's going on? Because this is actually really, really interesting. What you can see here is that I have this notion of pull replication. This is the hub on the cloud, and this effectively exposes an endpoint that is accessible. Remember that we set up the certificate for that. This is how we authenticate, and you don't necessarily have to give access to the database. You can give access just to that particular endpoint. And the idea here is that you're now able to have any number of nodes start pulling from the hub. The key here is that the entity that initiates the connection is the sink. So the Raspberry Pi is making the TCP connection to the cloud, and that means that it can go through NAT, don't have require port forwarding, none of that is required. It just works. I didn't have to set up anything on my end to make it happen. Furthermore, if you think about this, and we'll switch over here to the Pi actually have two tasks that are going to the cloud. One of them is the push to the cloud, and one of them is pull from the cloud. Both of them are being initiated from the Pi itself. I'm right now just running this on my own laptop. In real world, when I'm done developing, I'm going to take it out, stick it in the cupboard, and start working with it. It's going to have different network configuration, it's going to have a different IP, and you know what? I don't really care. It's not related. Everything will just work because the initiation point for everything is from the Pi. And that means that a lot of the networking complexity just don't exist for me. And this is how I get to have bidirectional replication between a Pi instance and the cloud, and everything works. Almost. There's one thing that I want you to think, and this is this fact. A hub is not meant for a single instance. Typically, you would use a hub to publish to many different instances. In the context of our recipe system, consider the case that I may have a bakery that have multiple locations. So what happened is that right now, if I make a change to the recipe on my local Raspberry Pi, it's going to get pushed to the cloud, and from there it's going to be distributed to all of the other locations that I have. It's even more cool than that, because think about what it means. Let's say that I'm currently down, there is a network error, whatever. It doesn't matter. The Raspberry Pi, we try to connect, we try to pull and push the data as necessary, so we have a local instance that can work completely independent if there is a need for that. But at the same time, if there is connectivity, it's going to be completely synced up. All of the locations are going to have all of the data, and everyone is going to be happy. So far, we've mostly dealt with the flow of the data. We set up the RavenDB instance on the Pi, we set up the cloud instance, we set up external replication and pull replication from the cloud, stuff like that. We have done some minor things with the Python client API. We made a query, we store some data, but nothing really interesting. The thing that I want to focus right now is the bakery scenario, but let's talk about what happened when we have multiple locations for a bakery. More interestingly, in each of these locations we have a Raspberry Pi, and we want to apply behavior at the specific location. Now, if we just had cookie cutter, every location behave exactly the same, it wouldn't be really that interesting. So let's say that in each location we need to have different behaviors. Because this is a demo and I don't want to get into more the complexities of real business software, we're just going to say that we have some locations which are vegan and some locations which are not, and we need to do some sort of handling of that. Let's go to the actual Raspberry Pi and see how we're going to handle that. This database is synced up to the cloud. Technically, I can store data that is local to the location that I'm using inside this database. And there are some scenarios that would require it. But it tends to be much simpler and easier to create physical separation between the two. So I'm going to create a new database, and this database will store all of the local data for that particular location. And this one is going to store all of the shared data. And now we need to have some sort of behavior among the different locations. So the first thing that I'm going to do, I'm going to think about what kind of location do I want to have. So you can see here I added this guy. And this is a menu, and this is a pattern that is called configuration document. So this is a document that has a well-known name. We're going to store that value inside the local database. Notice that the recipe object, the recipe document, is going to be inside the recipes database, and the menu is going to be inside the local database. There isn't really many interesting things except for this, which is the local configuration that we have for a location. Now, the next thing that I want to do, I want to start setting up some behavior. In order to set up some behavior, we need to figure out what we want to do. And the easiest way to handle that is that whenever we have a recipe in our system, whenever a recipe in the system changes, we need to verify whatever this recipe is a vegan recipe or not a vegan recipe, and based on that, add it to our menu. So let's see how we're going to handle that. Okay. So there's a whole bunch of stuff that's going on here. Some import statements that we don't care about. We already looked how the document store work. And here we see the first interesting thing. So if we tell RavenDB, we tell the RavenDB client, open a session to the local database. So we define the store to default to the recipes database, but now we override that for this particular instance. We load the well-known document, the well-known document, and if it doesn't exist, we create it. Nothing really interesting. This is where things get funny, because we have something called process batch. I don't know what this is. And we have these guys. So we have a subscription that's called updated recipes. And we're basically saying, okay, open that, it's working on recipes, and run it and pass it to the process batch. Right now, nothing really interesting. Let's go to the recipes database, settings, ongoing tasks. You might have gotten the feeling, but a lot of the power that we have in RavenDB comes from this particular location, all of the things that we can actually do. So we're going to create a subscription for recipes. And it doesn't really look that interesting. All we get is all of the recipes. So it looks just like a query. But wait for that. We'll see why this is important in a bit. Subscriptions are not queries. Subscriptions are actually persistent queries. Let's see what this means. So now we have updated recipes. And we open the subscription and we pass this a function. And this function is calling this function. What's going on? RavenDB will open the subscription and start sending us batches of documents. Whenever the client accepts a batch, it's going to call the process batch method because we call it here. And let's build the actual update from recipes method. Here's how it's going to look. We get the store and the batch. Notice that this is something really interesting. The batch is coming from the recipes database. We're opening a session on the local database. And let's see what's going on. We are loading the menu, and for each of the items that we got from the batch, and the item is a recipe, remember, we're saying scan the ingredients for cheese. I'm making my life easy with the vegan stuff and just doing a regex search for cheese or not. If the menu is vegan and the the recipe is not, we're going to remove it from the menu. If otherwise, if we can add the recipe to the menu, we're going to add it if it doesn't exist. That's pretty much it. Now, let's try to run it. So the first thing that's going to happen here is that I'm going to go to the local database. I'm going to get something really interesting. Remember that I did not create this database, this document. Create a database, but it was empty. Notice that the process is still running. We haven't actually stopped listening to updates, even though we've run through all of the documents in the database. We are still listening, and let's see what's happened when there actually are updates to the data. So we're going to go to the onion pie, and instead of cheese, we're going to say soy. And you can see that it added the recipe to the menu. And we can actually see that if we go to the, now I have 3 of them. If I add cheese back, this is removed. And you can see the changes as it happens. This is really interesting, but how do we tie it to the overall architecture? We have locations, and each locations have their own menu based on whatever it is, vegan location or non-vegan location, stuff like that. But how does the cloud plays into this? So let's go into the cloud and start making changes. Remember, I'm in the cloud and I'm hitting save. And here is a change. I'm going to do that again. You see that? What happens is that I'm changing something from in the cloud. It gets pulled into the Raspberry Pi where I have a subscription that is going to process that change. And based on the local state, based on whatever the location is vegan or non-vegan, I'm going to add or remove it to the menu. So now I have global behavior, global data, but local changes in behavior. And that can be an incredibly powerful architecture for your solution. So just to recap this entire thing, we have created an instance of RavenDB in the cloud. We have tied it to an instance of RavenDB running on Raspberry Pi. We have worked with that using a Python script running on the Raspberry Pi itself. We have tied all together with a subscription that is running on the Pi and apply local behavior and policy to data that we get from the cloud. We've also seen how we can take that and expand that to have the simple behavior of, similarly simple behavior of pull replication, where I can use that to disseminate data to many individual locations and then again apply the local behavior on that. This is what I have for this topic. I hope that you had a great time. If you have any questions, I would love to hear them. Thank you very much.